Hello, Drew Devitt here at New Way Air Bearings, and we have a supercritical CO₂ test core here. So it's a turbine compressor inside of here, a lot like a turbocharger or a turbo expander. So in here you can see the rotor is spinning. This is the turbine side on our externally pressurized porous air bearings. I can press down on it. It's got quite a lot of load capacity. And we have a small tube running into it here, so we're just going to flip it on and run it up for you so that you can. So we're just using a tiny tube to run this up to get it going about 9,000 RPMs with this, and when I turn the air pressure off, you can hear how quietly that runs. It's just completely smooth and frictionless. So now what we're going to do is take it apart and do some testing on the stiffness and load capacity. So we've removed the turbine shroud plate that was previously covering the impeller, and you can see the impeller is still spinning. I'm going to stop it here, and we're going to slide the indicator on it. There we go. So it's got about 0 on it right now, so turn the pressure off. There we go. So we see it go down about 8/10, comes back to 0, 8/10 down, comes back to 0. So of its own weight, it's flying about 8/10,000ths of an inch. Okay, so now we've added a 1, 2, 3 block that weighs 1.7 pounds. Turn the air off, comes to 0, turn the air on. So that's about 5/10 difference now instead of 8/10 with the additional weight. And you can see it's spinning completely freely. Now we have 2 blocks there, so 2 times 1.7, air on, air off. So this is about 3.5/10, so only about 150 millionths difference with the last 1.7 pounds. Finding the cap plates as a convenient mass, we've got about 17 pounds of load on this thrust bearing, and it's just barely grounding. So we're going to consider that, where it grounds. And over here you can see that this test is being completed at 60 psi. And you'll see here that it's about 15 standard cubic feet per hour total flow. So that's like 1/4 of a cubic foot per minute. And that's only at 60 psi for bar, and we're looking to see 10 times that input pressure to these bearings. Here you see the turbine part of in its vane plates, and it's got good load capacity radially and axially. And when you look down here, you can see the compressor impeller on the other end of the core, spinning completely frictionlessly. Taking the screw out of the compressor wheel, we're able to pull that off the bottom of the shaft. You can see we're using these shims to help give us a little extra axial clearance. And then here is the turbine. We can just pull that right out of the bearing assembly. Here you see the turbine with the 2 radial bearings and our thrust surface, and then the compressor wheel that presses on, and our thrust surface for that side. So you can see here the thrust bearing that's running up against the back of the turbine impeller. Now we'll just squirt a little alcohol on there. You can see the bubbles coming out of that externally pressurized porous air bearing. Right, so you see the bubbles coming out of the face of the bearing here. If you look to the drawing, you can see what we've done is added a little mass to the impeller but we've picked up a good bit of thrust area right here, and we're also running on the back side of the compressor wheel using these journals that were used by the rolling element bearing. So if we go down here, this is where the rolling element bearings were in the original design, and this is the modifications we've made to retrofit the turbo compressor with our porous media gas bearing technology.